am going to teach you 8085 architecture. Before that, you should know few basics about 8085 microprocessor. So 8085 microprocessor is a 8-bit processor. You know, already I told you 8085 microprocessor is a 8-bit processor. So it was first commercially successful microprocessor made by the Intel. The device has 40 pins. The 8085 microprocessor has 40 pins and requires plus 5 volt fixed power supply. So the operating voltage is plus 5 volt fixed power supply and the frequency range is also 3 megahertz. So this 3 megahertz is also generated by the crystal oscillator. So in the 8085 microprocessor, hence all the signals are classified into 6 groups. So that is address bus, data bus, control and status signals, power supply and frequency, externally initiated signals, serial I/O ports. So this is the 8085 microprocessor architecture. Here the functional blocks are ALU, interrupts, serial I/O control, set of register arrays, instruction registers and instruction decoder and control and timing signals, and here the address and data bus interfacing units. So first we see the 8085 microprocessor has 5 interrupt signal, that is INTR, RST 5.5, RST 6.5, RST 7.5 and track signal. So these interrupt signal is used to interrupt the executing program. So first one is a interrupt. So that is a INTR. INTR is nothing but interrupt request. So this is used as a general purpose request. Okay, wow. So INTR is a general purpose interrupt. That is a interrupt request. Next one is INTA. So INTA is a output signal. So INTA means interrupt acknowledge. So this is used to acknowledge the interrupt signal. So that is a output signal. Next one is RST 5.5, RST 6.5, RST 7.5. So here the RST means restart. Okay, wow. So RST 5.5, 6.5, 7.5 are restart interrupts. Here the restart interrupts are vectored interrupts. So the function of this interrupt is used to transfer program control to memory location. That means a specific memory location. So the function of restart interrupt is to transfer memory location. So next one is a trap signal. Trap signal is nothing but it is a non-maskable interrupt. So this is an interrupt of 8085 microprocessor. Next one is serial I/O control. Serial input output control. So here we having two signals, SID and SOD. SID is a serial input data and SOD is a serial output data. Here these two signals are used for serial transmission. The first SID input data is, it is used to receive the input and transmit the output data seriously. This is a function of serial I/O control. Okay, next I am coming to ALU. ALU, already I told you ALU. ALU is nothing but it is a arithmetic and logic unit. So ALU is a arithmetic and logic unit. It performs some computing operations such as arithmetic operation, that means addition, subtraction, and logical operations as logical operations and or XOR. These are all the logical operations. So the ALU will perform the arithmetic and logical operation, that means addition, subtraction. Logical operation means and or XOR. These are all the operations. Here the ALU will include the accumulator and temporary registers and flip-flops. There are 5 flags are there, flip-flops. So next I am coming to the accumulator. So accumulator is nothing but it is a 8-bit register. Okay, 8-bit register. So this register is also used to store 8-bit data because it is a 8-bit register. So it is used to store 8-bit data. So it is a part of ALU, arithmetic and logical unit. And suppose some operations will do in the accumulator. If arithmetic and logical unit means we will perform some arithmetic, addition or subtraction operations will do means the final result will be stored in the accumulator. So this accumulator is a special purpose register. So finally this accumulator is identified as register A because it is a special purpose register. So it is also identified as register A. Then next I am coming to temporary register. So temporary registers are also I have told previous classes. So temporary register, it is a 8-bit register. So temporary register is nothing but it is used to hold the data. Just it is used to hold the data during that ALU operations. Okay, wow. So it is just used to hold the data during ALU operation, addition, subtraction or OR operation, AND operation, something. Next one is a flag register. So basically flag register is a 8-bit register. Okay, wow. So 8-bit register, but we will use only 5 bits. So this flag register having 8 bits, but we will use only 5 bits. Here the 5 flags are presented, that is sign flag, zero flag, auxiliary carry flag, parity flag, carry flag. First one is a sign flag. The sign flag is represented by S flag. Suppose when the S is equal to 1 means the ALU operation is equal to 1. Then only the sign flag will be activated or is equal to 1. Okay, wow. So next one is zero flag. Zero flag is nothing but suppose when the ALU operation shows you a 00H. So that means the zero operations will be, zero flag will be activated. So that means nothing but the ALU operation, that is ALU result is 00H means the zero flag will be activated, that is Z flag will be activated. Next one is the auxiliary carry flag. Auxiliary carry flag is nothing but it is does not accessible by the programmer. So this is only used by the computer. The main function of this auxiliary carry is it is only used for BCD addition. So already I told you BCD addition. You have studied already in the digital design classes BCD addition, subtraction. So in the auxiliary carry is used for only BCD addition. Suppose the AC flag is equal to 1 means if the carry from lower to upper, what the carry from lower to upper barrow is carried or higher, sorry lower higher to lower means it is carried by the auxiliary carry flag. Then only it will be activated, then is equal to 1. This is the auxiliary carry flag. Next one is a parity flag. So parity flag is also represented by P flag. So whenever the result is in even parity, then the parity flag will be activated. So whenever the result is in even parity, that time the parity bit, the parity flag will be activated. Next one is CY flag. CY flag is nothing but carry flag. So carry flag, whenever the result is based on the carry means at that time the carry flag will be activated. So these are the 5 flags of the flag registers. Next I am coming to set of register arrays. So first W and Z registers. So W register is a 8-bit register. At the same time the Z register is also 8-bit register. But these two registers are does not accessible by the programmer because these two registers are temporary register. So temporary registers means it is used to hold the data. So it is used to hold the data, but this is does not accessible by the programmer. So next, below the temporary registers having B, C, D, E, H, L. Totally 6 registers. Here the 6 registers are also called as general purpose registers. Okay, so B register having 8 bits, C register having 8 bits, D register having 8 bits, E register having 8 bits. Normally H and L registers also having 8 bits. So this is also used to have a store 8-bit data. But these general purpose registers are also called as scratch pad of RAM. That means a scratch pad of RAM of 8085 microprocessor. Here in the register array, these register here below the temporary register, these 6 general purpose registers are also called as extended pair of registers. Suppose somewhere we need to use 16-bit number, okay, because BCR, the total below the general purpose registers are 8-bit registers, but we need 16-bit data. So that time these registers are paired, okay, so because it will need 16-bit numbers, but each and every registers having only 8-bit. So that reason these registers will be paired 16-bit. So these are also called as extended pair of registers. So below the register array having a stack pointer. So stack pointer is nothing but it is a 16-bit register. So the function of stack pointer is nothing but it is used to memory pointer. So that is used for only memory pointer, but the stack defines also the 16-bit address of the memory. So next one is the program counter. So program counter is also nothing but it is also a 16-bit register. It is also used to act a memory pointer. So next one is the increment or decrement address latch. Suppose the data will be increment or decrement, means it is used for the increment or decrement address latch. So below this register arrays, we are having address bus and data bus. Okay, so address bus is nothing but, so it is having 16 group of address lines, that is a address bus. So the job of address bus is to identify the location, just to identify the location of the memory. Okay, so various locations in the memory, you don't operate to all hold the memory at a time. You need to operate one location at a memory. So the job of address bus is used to identify the location. So the address bus is also unidirectional. It is a group of 16 address lines, and the next data bus having group of 8 lines. Okay, so the data bus is nothing but it just carries the data. So address bus is carries just only the address, but the data bus is used to carries just data. So first the job of address bus is used to identify the location. So after identification, the data bus will be activated. That means after identification of data bus, the address bus is used to transfer the data from microprocessor or microprocessor to any other peripheral devices. So these are the address and data bus. That is the memory interfacing units. Next I am coming to timing and control signals. Here the X1 and X2 are the 2 pins of the 8085 microprocessor. Here these X1 and X2 are the crystals. It will be generated some signals, that is a clock output. The clock generates the clock output. Next one is a ready signal. Ready signal is nothing but it is used to synchronize the other peripheral devices with this microprocessor. Just synchronizing the peripheral devices with this 8085 microprocessor. And coming to RD and WR. RD is a read and WR is write. These two RD and write are the control signals. Whatever it is a read or write. When the operation, suppose we need to read or write on the data is on the memory. Next one is a ALE. ALE is nothing but it is a address latch enable. So it is used for latching the lower order address. Okay, so ALE is nothing but it is a address latch enable. It is primarily used to latching the lower order address bus. That means lower order address bus. So next one is the status signals are there, S0, S1, I0. So status signal is nothing but it is when the data is read or write to be selected, or these are the status signals of the 8085 microprocessor. Next one is the hold and HLDA. These two signals are activated by just the external key. So the external key only it will be activated, hold and HLDA signals. Here these two signals are used for the DMA, that is a direct memory access. That purpose only it will be used in the 8085 microprocessor. Next one is a reset pin. So reset pin is nothing but it is also activated by the external key. Suppose if you use the reset pin, okay, suppose if you use in the reset pin means it will suspended all total internal operation of the 8085 microprocessor. It will be resetted. It is the reset pins, that is the reset in and reset out. These pins are used to suspended the total internal operation of the 8085 microprocessor. And next one is the instruction register. Already I told you every 808, every microprocessor having a set of instructions. So each and every instructions has to be stored in the instruction register. Suppose if you want to fetch the memory from the instruction, so it will be loaded in the instruction registers, and finally after loading and finally it will be decoded by using the instruction decoder. So these are the internal architecture, internal functional blocks of 8085 microprocessor. So once again I told you the various blocks are there. First one is a ALU operations, set of register operations, and arithmetic address and data bus units, timing and control bus signals, instruction registers and instruction decoders. In the above the data bus, the interrupt control and serial IO controls are there. So ALU is arithmetic and logic units. It performs which operation? Arithmetic and logical operation. Arithmetic operation means addition, subtraction. Logical operation means and or operations. So it's a next one is a accumulator. So accumulator is a 8-bit register. It's a part of ALU. It will be used to store temporary register. It will be used to store 8-bit register because it is a 8-bit register. Okay. Next, temporary register. So the function of temporary register is to store a data. Next one is a flag register. What are the types of flags? S flag, sign flag, zero flag, carry flag, auxiliary carry flag, parity flag. Sign flag is represented by S, carry is represented by CY, auxiliary carry is represented by address bus is nothing but it is a group of 16 address lines, and data bus is nothing but it is a group of 8 data lines. Address bus is only used to carries address, but the database is used to carries the data only. So the job of address bus is to identify the location. Next one is the control and status signal. So these are the control and status signals. ALE, read, write. ALE is nothing but already I told you address latch, enable, and read and write are the active low signals, active low control signals. Next one is the frequency control signals. X0 and X1 are the two pins of 8085 architecture. These pins will be generated clock input signal. So this is a overall picture of the 8085 microprocessor. Thank you.